Hello, hi. Once again, welcome back. Virtual assistant is the problem to represent the voice mode search, of course. Problem statement, lot of typing, so there is need for that. Just by the use of your voice, you may need to collect as various types of researches you need for this project. Implementing a voice search to solve that problem of overtyping. Authors Frank Seika Ndiako is my name. Bayesian and everything. With the dataset, that's the link. It's a common voice dataset, high quality source of and multi-language dataset of voices for training speech and the technologies. That's the voice that a common voice dataset that I'm going to use. Or you may call it as a speaker speech conversational dataset. Because that's the one that I'll be using, just collection of text, collection of audios from a user and conversion to text format. So that's it. Okay, factors considered: time spent on the web, because while everyone or a person is typing, there's time that is spent while you're typing. You may face problems like maybe spellings, all of that, Okay, don't mind about that. Just by the voice of yours, of your body, you can get what you want. For example, I don't know, I can show you, but try using the Google Assistant, then you know more about what I'm saying. So another problem is the repetitive, another factor you consider, repetitive strain injury, that is RSI. And this happens due to overtyping, may contain may cause certain body disorders, as mentioned, like that. Of course, that is a very big disorder that happens to everyone. Most of those who are using the keyboard like all over half a day, 24 hours. To those who are like too much of the programming, don't mind. So another one, we have the disabled view. For example, this will help this will help the disabled be able to make various researches from the web according to their choices. For this, I can give an example of a blind mother trying to impress a quiet little baby. So a mother would just speak and be, "Hey, play for me this movie," and the baby may be quiet, or any music, of course. And another one, it is also for self-study. This dataset will allow me to go into details of what I'm supposed to do, and by doing so, I'll be learning. Hence, knowledge transfer. Of course, anyone can have a different kind of self-study in any of the work that is given. Don't mind about that. So, features: there is language weighting. Language weighting. This improves precision by weighting specific words that are spoken frequently. That is to say, product names or industry jargon. Beyond terms already in the base vocabulary. Excuse me. We have the speaker labeling. This output a transcription that cites or tags each speaker's contribution to a multi-participant conversation. Next, we have acoustic training. This attends to acoustic side of the business. For example, that is the ambient noise in a call center. This will help, like in case you are in a crowded place, the speaker will be helping just to recognize a voice that is more clearly, that is you, maybe closer to it. I have profanity filtering, and this uses filters to identify certain words or phrases and sanitize speech output, of course. Okay, go to the next slide. Now, besides that, there is what we call Bayes' theorem. It states that the condition probability of an event based on the current of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. I have no further explanation for that, but that's the theorem. I can't change or explain further. And the naive Bayes is just a simple learning algorithm that utilizes Bayes' rule together with a strong assumption that the attributes are conditional independent given the class. Oh, you may say that just a classifier, and is an algorithm that uses Bayesian theorem to classify objects and so forth. The difference between Bayesian and naive Bayes, well, this naive Bayes is a simple learning algorithm that utilizes Bayes' rule, while the Bayes theorem is just a conditional probability of an event based on the occurrence of another event. So that's the simple difference. So what is a Bayesian network? These are just ideas for taking an event that occurred and predicting the likelihood that in one of the several possible known cases causes was the contributing factor. For example, Bayesian network will represent the probabilistic relationship between diseases and symptoms. So I think that example can explain better. Difference between the naive and Bayesian network. Naive Bayes assumes the conditional independence, whereas for Bayes networks will allow the user to specify which attributes are in fact conditionally independent. Well, you need to know that the distinction between Bayes' theorem and naive Bayes is that naive Bayes assumes conditional, whereas the theorem does not. This means the relationship between all input features are independent. Maybe not a great assumption, but this is where the algorithm is called naive. Summarizes all of that. I have the link to the GitHub. That link will direct you where the source code will be. And this one is just for those. It was just my referral as I was looking for my data set. And also follow the second one. You can see to create virtual assistant apps like Siri and Google Assistant. All of those links. There is also this one. This is where I find and I obtain the one of the common voice. You can search on it. The last one, just I used it to obtain the naive Bayes. Thank you, everyone. Subscribe, like, and comment. Good, whatever day you are in, night or evening.